An event to talk about the Great Reset. And by the Great Reset, what George, I think, is referring to is the reset of what really Bitcoin and blockchain technology was meant to be in the first place. And so I grew up in the 1970s, 80s, and 90s. And at the time, the big movie was Back to the Future. Who was a Back to the Future fan? Yes, good. Some of you are showing your age. And Back to the Future was important, me too, that's right, because it was this concept of having to go back in time to save the future. And that's exactly what we and allies of ours are doing now, to go back in time to the birth of Bitcoin to save its future. And if you remember the movie, it wasn't just Michael J. Fox who had to go back in time. He had the help of Doc, right? Crazy Doc, the crazy chief scientist of this really amazing project with goofy eyes, white hair, and I get the fortune to work with a crazy chief scientist as well. It's Dr. Craig Wright, who is very well known and controversial in the Bitcoin and cryptocurrency world because of his views on Bitcoin, and of course some people believe he is involved in the creation of Bitcoin and other people believe he wasn't and is a complete fraud. In my mind, it doesn't really matter because his views about what Bitcoin are central to the future that we are all trying to achieve. I want to remind you, it's been 10 years since the birth of Bitcoin, which came into the world with this paper, the Satoshi Nakomoto white paper, which birthed Bitcoin to be a peer-to-peer electronic cash system. That was very critical to the vision of what Bitcoin was supposed to be. But if we're really honest, Bitcoin has not achieved its full vision. And that's why you've heard tonight from other speakers about this whole world of other coins, ICOs, and supposed blockchain projects that have emerged. And the only reason they emerge is because Bitcoin wasn't allowed to achieve its full vision expressed by the Satoshi Nakamoto white paper. It's because Bitcoin did this. It took different forks and multiple roads as opposed to going on the singular line and path that Satoshi Nakamoto envisioned. And it's why we and our allies at CoinGeek, which is both a media and mining site and an investment collective, and Nchain and a number of other people around the world are throwing all of our organization support and resources behind the rebirth of original Bitcoin in the form of Bitcoin SV. And tonight I want to tell you about why we believe Bitcoin SV is going to fulfill the Satoshi destiny to become the all-in-one coin so you don't need others, and the single global public ledger of the future. It's named SV in recognition of our mission to fulfill the Satoshi vision for Bitcoin. Because, as I'll explain tonight, we believe Bitcoin SV is the only version of Bitcoin that exists and will ever exist that adheres to the Satoshi white paper, the protocol that was set forth, and the core design that was expressed by Satoshi. And another thing I'm going to emphasize tonight is the importance of the true genius of Bitcoin. A lot of people like to think that Bitcoin was this technological marvel. In a lot of ways it isn't. It was a combination of technology things that had existed in the past, put together very cleverly. But its true genius is an economic incentive model that incentivizes miners and other participants in the system to maintain a single global ledger that is not controlled by a central authority, and to issue what is an electronic cash meant to be used by the world, as well as maintain a blockchain that has immense capability if it was ever allowed to achieve its full potential. So today I want to do three things. I want to express to you the story of Bitcoin's history and why we ended up in a world with so many coins that all of you are sitting here thinking, well, should I invest in them? And I'm not going to tell you what to invest in or not. I'm just going to tell you that we believe there's only going to be, at the end of the day, one global public blockchain, and that's going to be Bitcoin in the form of SV. Second, I'm going to tell you about how it fulfills the Satoshi vision. And finally, I want to express some of the exciting enterprise applications that I think are coming if we actually allow Bitcoin to be unleashed to its full potential. So what happened with Bitcoin? Well, Bitcoin got birthed in the world. 10 years ago, actually in January, just last month, was the Genesis block on January 3rd, which started the Bitcoin blockchain. And then Bitcoin continued for a period of time, but it never really scaled to become this global powerhouse, to be used, as people are talking about, in daily life. And the reason is because, after a period of time, Satoshi disappeared from the online forums and email communications that Satoshi started with, and left the development of Bitcoin in the hands of a development group which became known as Bitcoin Core. Over time, for various reasons, Bitcoin Core imposed a number of restrictions and limitations on Bitcoin, which limited its potential. The main one was the block size, which was kept at 1 megabyte in size, which is very, very small. This was intended to be a temporary restriction on the block size in the very early days of Bitcoin. But Bitcoin Core kept it at 1 megabyte, which, as you can see here, only allows the chain to average about 3 transactions a second, and at maximum 7 transactions a second. If you want to create a global electronic cash system that's nowhere near large enough, where you compare the global Visa network, which averages 2,000 transactions a second, and during peak periods reaches 56,000 transactions a second. So at 1 megabyte in size, you have a very slow, not very large-scale chain. And that's because Bitcoin Core decided to support other options for trying to process transactions off of the chain, what we call off-chain solutions, or layer 2 solutions such as the Lightning Network, where the transactions happen at a level that's different than the blockchain and periodically settled to the blockchain. That's not the Satoshi vision, and that's why we saw about a year ago increasing transaction fees on the BTC, what we call Bitcoin Core network. Here's a chart of the transactions fees from February 2017 to January 2018. It's a little light in this room, but what happened was there was this huge spike in the transaction fees. And that was because the mempool, the waiting period for transactions, if they couldn't fit into a small 1 megabyte block, that got larger. And when transactions have to wait somewhere, you have to essentially pay miners more money to get the transactions onto the blockchain. And that led to a situation back then where it was costing 20, 40, sometimes even 50 US dollars to send a single transaction. And of course, that's just not how a world money system can work. No one's going to go to a Starbucks coffee, pay $5 for the coffee, because you want a very fancy Starbucks coffee, and pay 20 US dollars for a transaction fee. That's just not the way Satoshi envisioned it, because it was meant to be, as you remember, a peer-to-peer electronic cash system, meaning you should be able to use Bitcoin like cash. And so that was what was derailing the future of Bitcoin, and that led to lots of disagreements and battles within the Bitcoin community. And it led to the birth in August 2017 of a fork of Bitcoin called Bitcoin Cash that was designed to try and pursue a bigger scaling roadmap so that the blocks would get bigger, you could fit more transactions in them, they could be processed faster for much lower fees. So when Bitcoin Cash emerged in August 2017, it went to 8 megabyte blocks as its default block size, as a path to start increasing. And we, at Nchain, decided to throw our support behind Bitcoin Cash because we felt this was a path to try and restore that original Satoshi vision. So we worked with the other developer groups that were involved, and as part of certain protocol upgrades in May 2018, the block size went up even more to 32 megabytes in size, which is nice, but in the scheme of a world global cash system, is still not large enough. And we continue to work with them to try and move along this Bitcoin Cash development. But last year, it became clear to us that there was significant desire by Bitcoin ABC, which was the lead developer group for Bitcoin Cash, to start making significant changes to the core Bitcoin design and protocol. I don't want to get too technical here, but there were things such as introducing what's called canonical transaction ordering, changing the way transactions got ordered into a block, adding a new opcode. These are operating codes in the Bitcoin scripting language that can be used for different functions, adding one that wasn't part of the original Satoshi design. And they weren't prepared to scale as quickly as we thought was necessary to move Bitcoin along its path. The bigger issue, though, was that a philosophical difference emerged, and it was similar to what happened with Bitcoin Core, with Bitcoin Cash's lead development teams. There's this innate desire sometimes by developers to try and show, I know better. I think I can fix Bitcoin. I think it has problems and I can change it. And there is this continued, repeated desire by the developers to constantly want to experiment with changes to the Bitcoin protocol. So every upgrade that would happen every 6 months, that we would have this discussion, well, I want to add this code, I want to change this feature. And our belief was that the original Satoshi design has everything it needed for Bitcoin to survive and to flourish, and we should not be disturbing it, because when you disturb the protocol, you risk upsetting the economic incentive balance that was so carefully constructed in Bitcoin's design. And that's what led to a huge battle, which you probably read about in the media, where we birthed the creation of a competing implementation for Bitcoin Cash called Bitcoin SV, Satoshi Vision, and essentially fought a hash war over control of the Bitcoin Cash chain. That was a contentious hard fork last November, and for a period of time it caught a lot of attention. Eventually, the fork resolved by Bitcoin SV emerging as its own separate chain and now permanent token. So now, if you're thinking out there in the public, you're thinking, oh my God, there's 3 Bitcoins now. There's Bitcoin Core, there's Bitcoin Cash, and now Bitcoin SV. What does this all mean? In our view, really only Bitcoin SV is pursuing the original path for Bitcoin, and the others have essentially forked off. Here's a good diagram I've seen on Twitter that illustrates this. The Bitcoin blockchain birthed in 2009 and continued on. In 2017, Bitcoin Core, in addition to keeping the block size small at 1 megabyte, they introduced this thing called segregated witness as an attempt to try and increase the capacity of the blocks. And we seriously disagreed with that, because what that means is segregating or separating the witness, meaning the digital signature for the transaction. So the digital signatures got stored somewhere else, essentially cutting off the digital signature. And the reason that was a huge problem, in our view, is the very definition of a coin in the Satoshi white paper is that it is a chain of digital signatures. You cut off the digital signatures, you essentially change the fundamental design of Bitcoin. When they introduced that in 2017, that's when Bitcoin Cash emerged, to keep a chain going. Down the middle there, you can see it in green, which didn't have segregated witness. And then, last year, that's when all of the other disagreements emerged, where Bitcoin ABC wanted to introduce more changes, and that's why we fought to preserve and defend the original Bitcoin in the form of Bitcoin SV, which is the only chain now that continues what Satoshi started way back in 2009. So, even since the hard fork, Bitcoin ABC, during the hash war, and since then, have introduced a whole bunch of other changes. I won't even go through the technical nuances there, but they added what are called checkpoints. They added what are called 10-block reorganization defenses to be able to essentially usurp the role of miners to determine what is the valid blockchain. They've announced this concept of avalanche, which is a pre-consensus mechanism for miners who are selected randomly, or not so randomly, to essentially pre-decide what the blocks are going to be, moving that chain to more of a proof of stake rather than proof of work business model, which is, again, antithetical to what the Satoshi design is. If you read the Satoshi white paper, it is all about relying on proof of work by miners to validate the chain. They're not increasing the default block size anymore. Even though they thought they were going to increase it in their next upgrade, they're staying at 32 megabytes in size. So that's what happened that brought us to this place where we have Bitcoin SV now. So now I want to explain to you how we are working with Bitcoin SV to bring back the Satoshi vision, to do the great reset, and to really allow Bitcoin to do what it should have been allowed to do many years ago. First, we're focusing on keeping a protocol that is stable, not having developers constantly change it. Satoshi envisioned this, writing way back in 2010. The nature of Bitcoin is such that once version 0.1 was released, the core design was set in stone for the rest of its lifetime. I want to repeat that. The core design was set in stone for the rest of its lifetime. That is what Satoshi intended way back in 2010. But as I've explained, that's not what happened. And that is why the Bitcoin vision never realized to its full potential. In fact, the only reason Ethereum exists is because Vitalik Buterin actually wanted to create Ethereum on Bitcoin. But Bitcoin Core would not re-enable a lot of these Satoshi old opcodes, raise the block size in a way that would allow Vitalik and his partners to do that. And if it had been done on Bitcoin, we wouldn't be in this world with thousands of ICOs all done on Ethereum using the ERC20 protocol. And so that's what happened that led to where we are today. We believe it's critical for any protocol to work and for big businesses to build upon it, that you need a protocol that is solid rock, not moving sand. You want to build a house? You don't build a house on moving sand. You build it on solid rock. We envision a world where businesses all over, the biggest ones, build their applications on the Bitcoin blockchain. But for that to happen, the protocol cannot keep changing every 6 months, where some developer says, hey, I want to test some new opcode. Hey, I want to change how the transactions are ordered. Can you imagine Amazon or Alibaba saying, oh yeah, I want to like build my project on that, but not knowing whether in 6 months the protocol will change or not? Compared to the internet protocol, we've had the internet for a number of decades, but its actual protocol, the IP protocol, has changed very slowly over time. And that is what has allowed businesses to have the comfort to build their websites, their applications, their mobile apps, their social media platforms on the internet because of that stability. So what are we doing? Our focus and our roadmap is very clear and simple. We are going to restore the Satoshi version 0.1 client software, the very first version of the client software that got butchered and hacked along the way by developer groups. That means we're going to restore all the original Satoshi opcodes because we, unlike other people in Bitcoin, believe the original Bitcoin design and software had everything it needed to succeed and has never been allowed to, and we're going to let that happen. We're going to safely remove any remaining limits, such as the block limits that were imposed and others that were imposed on data size for certain features. So for example, for the first release that we did in November of the client software for Bitcoin SV, we restored those opcodes you see there. We removed a limit of the number of opcodes per script. And in addition, we raised the default block size on SV to 128 megabytes. Not 1, not 8, not 32, but 128 megabyte blocks on Bitcoin SV. And after that, we don't want any more changes. Leave it alone. Let the protocol just remain stable once we're done restoring the Satoshi design. And that will create more certainty for all the participants in the ecosystem, whether you're an enterprise, an application developer, an exchange, or a miner. Anyone will benefit from this stability. The restored opcodes that are part of the original Satoshi design have everything that's needed to do the things the other tokens and coins claim you need to do. Tokenization, for example, smart contracts. That's all coming as developers are creating solutions for them on Bitcoin SV. Secondly, we are focused on scalability. The problem that most blockchain projects have is scaling. Ethereum has this problem. How do you get the chain bigger so it can process lots and lots of transactions for a worldwide network? Satoshi believed way back at the beginning that Bitcoin had the necessary capacity to scale. Satoshi wrote, the existing Visa credit card network processes about 15 million internet purchases per day worldwide. Bitcoin can already scale much larger than that with existing hardware for a fraction of the cost. It never really hits a scale ceiling. So this is 10 years ago. Satoshi already believed at the time that with hardware back then, which was, archaic compared to today, that Bitcoin could scale faster and bigger than the Visa payment network. But it wasn't allowed to do that. And Satoshi believed it would never really hit a scale ceiling. And this is critical for Bitcoin's economic incentive model. You have to remember that every few years, the block reward that a miner gets for hitting a block cuts in half. It started at 50, then it went to 25, right now it's 12.5. Next year, it's going down to 6.25 coins. So for a miner to stay profitable, the miner has to make up the lost block reward value with higher volumes of transaction fees, which means you have to get bigger blocks to allow much larger numbers of transactions of different types, not just payments, but tokens, smart contracts, and data transactions, in a global data ledger. That's what the Bitcoin blockchain is supposed to be. It's a global data ledger. And Satoshi envisioned this way back in 2010, saying that the transaction fee will become the main compensation for nodes. I'm sure that in 20 years there will be either very large volume of transactions or no volume. Because Satoshi knew, as the block reward cuts in half, then you need to make up value in higher volumes of transaction fees. And so that's why, as I mentioned before, BTC, Bitcoin Core, is stuck at 1 megabyte blocks. BCH has 8, and then went to 32 megabyte blocks. And we started with 128 megabyte blocks, but that's just the beginning. We're intending later this year to raise the default block size on Bitcoin SV to 512 megabytes, probably within the next year or so, get to 1 to 2 gigabytes, and eventually move to a world where there is no limit. There's no default limit, and you let miners configure what block size they want to accept themselves and create a competitive marketplace for miners, just the way early Satoshi writings envisioned. We've tested this already with Biggerblocks. We've worked with a professional stress test team to see Biggerblocks on the SV blockchain. And on November 19th, we had a 38 and a 64 megabyte block hit by different pools. And then on Christmas Day, Mempool, a pool in China, did a 65 megabyte block. And then on January 3rd, the 10-year anniversary of the Genesis block, they mined a 103 megabyte block. These are the largest blocks ever mined on a public blockchain. But we know that's just warming up, because those are just sort of individual blocks that happen here or there. For a blockchain to really be successful at scaling, you need the capacity to have sustained blocks that are big. And so our team created a scaling test network for Bitcoin SV and just recently published some results of that testing on the test network. And they were able to demonstrate sustained 64 megabyte blocks for a full 24-hour period of time, as you can see here from this graph. That's 270 transactions per second sustained for a full 24 hours. Their testing also was able to get sustained 128 megabyte blocks with some more difficulty because they're still working on software solutions to make it easier and better for the transactions and larger blocks to be propagated across the network. And that's the technical work that still has to be done. You don't just lift the block size and boom, the network's faster. Developers have to work on solutions to improve the propagation of the transactions and the blocks. And they are working on that to achieve a day which we believe will happen. 1 terabyte size blocks, 1 million megabytes. And if we ever achieve a network of that scale, that means each block, which is on average 10 minutes, would hold 4 billion Bitcoin transactions and provide capacity of 7 million transactions a second. That is far more than you need for a global cash system of payments. But it's because we believe the Bitcoin ledger should be the global public ledger, where big businesses are using it to do their data transactions of all types. And in answer to the question that was posed earlier, we believe there will only be one global public ledger. We operate on one internet. There might be an Amazon, there might be an Alibaba, there might be a Walmart e-commerce, but they don't all operate on different internets. That would be ridiculous. How many internets would you need if you turned on your phone and said, oh, which internet do I log on to in order to connect with this particular app? The internet works because there's one. There will be one global public blockchain, and only Bitcoin in the form of SV has the scaling roadmap and the stability roadmap, and more importantly, the dedication to achieve that vision, which is not what other blockchain projects, ICOs, or SEOs are even attempting to do. That is the big difference in what our vision is and why we exist both as a business and as an advocate in the Bitcoin space. Finally, let me conclude by talking about some of the power that enterprises can benefit from in this world, which is, yes, Bitcoin's supposed to be an electronic cash system, but the power of it for enterprise applications is immense. First, tokenization is already capable of being done on Bitcoin SV. Our partners at CoinGeek with us ran a £5 million tokenization contest last year to find the best token solution. And the winning team developed what's called Tokenize. You can check out the protocol at tokenize.cash, which is a system for issuing, managing, and trading tokens only on the BSV blockchain. So the solution is exclusive to BSV. And why were we impressed with them? One, they had a good technical solution. But designing tokens is not anything technologically marvelous. There's lots of solutions to do that. But the reason we were impressed by their protocol is, one, the breadth and number of assets which they had designed a system to tokenize. Because we're not big fans of ICOs where people just create a coin to try and raise money and get out of it and pump and dump. We believe in a world where you can tokenize real-world assets and allow them to be recorded and traded on a blockchain. And that's perfectly legitimate. And so their solution provides support for over 50 different asset types. Shares, like common and preferred stock of companies, bonds, derivatives, hybrid securities, utility tokens used by consumer-facing companies such as coupons, currency tethers, transportation tickets, your airplane ticket, your bus ticket, event tickets, concert tickets, as well as even carbon credits in the energy space to be tokenized, traded more efficiently through blockchain solutions. But more importantly, we recognized and appreciated that this team designed a solution that was built for legal compliance, something people in the token world often don't want to talk about. Because we recognize, as well as this team, that tokens must exist in a real world of real laws. And so their solution makes it easy for businesses who are the issuers of the tokens to be able to comply with whatever laws govern them in their jurisdictions. So for example, the ability to revoke and restrict the transfer of tokens. That's critical for compliance with securities laws. Whereas other people in the Bitcoin and blockchain space want fully permissionless tokens, where once you issue the token, you as the issuer can't do anything about what happens to it. And the reality is that a big business is not going to tokenize their assets or issue a token if they can't have some control over what happens with them. Read your loyalty and rewards points, membership terms and conditions. That's what your airline will say. You know, they have the rights to transfer or to revoke or restrict transfer of your points. They'll never tokenize them onto a blockchain unless they have that right. And that's what that company allows. Some other exciting developments. Our friends at Handcash is this startup in Spain that I want to tell you about. Nchain has a private investment arm, and we invested in Handcash. It's got one of the rated top 3 cryptocurrency mobile wallets in the world because it uses near-field communication technology, NFC, as you can see in this picture, where if I've got the app on my phone, which I do, and you do, I can just put my phone next to yours and send you Bitcoin. Because they wanted Bitcoin to be like cash, so you could hand it to somebody. And so they're working, of course, on merchant solutions to be able to pay at terminals that way, kind of like Apple Pay or Google Pay. But they also have enterprise solutions they're developing, Handcash for Business. One of their applications is called Cashport. It's an API that makes it easy for any company with a website, a mobile app, or a game in particular, online games, to integrate Bitcoin SV micropayments because they only operate on Bitcoin SV. So that you can add micropayments to your apps and games. This will open up a whole new way, particularly for game developers and operators, to generate revenue. They have a very friendly SDK that operates on all of the major operating systems, such as iOS and Android, to make it really easy for a company just to connect their API in to start accepting Bitcoin SV payments. That opens up new business models. If you're doing a video service, maybe now instead of paying for full video, you could charge people to pay per second with Bitcoin SV micropayments. You could reward individual interactions on social media. Anytime someone likes, shares, or comments on particular posts, there could be a micropayment delivered to them by an advertiser, for example, who wants to promote a brand. Behavior-based payments, and it makes it really easy for one-click purchases. The first company which has used this Cashport API is another startup called Keyport, which I've been following. Entrepreneurs that are really exciting out of India, they've created a video service, kind of like YouTube, on the Bitcoin SV blockchain, where content creators upload videos, and if it's me and I've got $2 in my Bitcoin wallet, I can pay through their API to the content creator, the video creator, let's say this team called Bitcoin Beyond, a cent a minute, and Keyport TV automatically gets into its Bitcoin wallet a small fraction as its share for providing the service. It opens up new ways for providing video as well as any other type of content access online. One of the most exciting things that's happened just in the last week, and this gets back to the concept of restoring the original Satoshi vision with no limits. And that is with what's called the op return field. Op return is an operating code in the Bitcoin scripting language. And it is a way to embed data in a Bitcoin transaction. So here's a diagram of what a typical transaction looks like. You have an input and an output, where a transaction keeps track of how many coins are going in and then how many coins are going out, to say it most simply. But you can also add in the op return field some text or data. In this transaction example, op return, just the phrase "you hello" is added. You can add all kinds of data. It could be different kinds of files, for example. But the Bitcoin core developer groups, for whatever reason, because they were worried about more data coming to the blockchain, decided to restrict the size of data you could embed into that Bitcoin transaction. And so they limited it to 80 bytes. And at one point it was only 40 bytes. And then when Bitcoin Cash was birthed in 2017, that was lifted to 220 bytes. But just about a week ago, our lead developer, Steve Shatters, figured out a way to have no limit on that data size without a consensus protocol change, even though we could have done that as well. And so miners, including our mining group, started setting to 100 kilobytes, which is 100 times 1,000 bytes, which is a lot bigger. And that means you can embed larger data files into an op return transaction, so that if I send Jeff here a Bitcoin transaction with money in it, I can also embed data and files and pair the payment of something with transmission of data. And what has happened within the past week has been really amazing. Developers all around the world have been experimenting with powerful new usages for this data size that's been lifted with no limit. Steve, our lead developer, he sent out the first transaction where he took the entire text of the book Alice in Wonderland and embedded it in a single op return push. 53 kilobytes of data put in one Bitcoin transaction op return. And then Unwriter, who's this mysterious, unknown, but most prolific developer in the Bitcoin world, took that and went, aha, I'm going to run with this whole Alice in Wonderland thing, because Bitcoin developers love that. They love blue pills and red pills and all those rabbits. And so he then constructed a serverless website, where there's a website, you can go visit it at that URL, where the content and the data for the website is all stored in a single Bitcoin transaction op return push. And the website runs without a server from that Bitcoin blockchain transaction, which is pretty amazing. And then there's more. Memo.cash, which is a popular social media platform that operates on the Bitcoin SV blockchain, has now enabled the embedding of PNG and JPEG images directly into posts on its platform and then forever into the blockchain. So it did a first test with this. It's a picture of part of the Bitcoin white paper, Section 8, about simplified payment verification. And then there's another developer, his name is Nygeun, who's just been playing with all cool new usages. He's embedded a chess game, a clock, and even a whole music file of classical music in single op return transactions on the Bitcoin blockchain. So it's been pretty amazing to watch. And if you want to get really bigger in terms of how does this turn into a business for enterprises to use the blockchain this way, someone launched bitcoinfiles.org. It's basically Dropbox on the blockchain, where it is a content delivery network on Bitcoin SV, where you can store and access any type of files, images, text content, Word documents for a fee. You pay Bitcoin SV for it, and you can access it with micropayments of Bitcoin SV. Treating Bitcoin the way it was supposed to be, a ledger, a record-keeping system that's also used for a global payment network. So what does this mean? It means that with the limits lifted, and that will continue to be lifted by our team to get Bitcoin back to the original Satoshi vision, Bitcoin SV can and will be, in our view, the world's new data carrier and storage network. But the advantage, compared to just another data carrier and storage network, is that the storage and the transmission of data happens with a payment transaction. So you can do cool new business models where data and content are being transmitted with payment, and unlocking or locking access to payment. And that is why we need much bigger blocks. You can't keep these small blocks and make this work. The final thing I'll end on is this amazing concept of the metanet that our chief scientist, Craig Wright, announced at a big conference in London in December. He thinks this stuff with op return is cute. We just spoke at a conference in Japan together yesterday. And after I spoke, he said, yeah, Jimmy's excited about op return and data being embedded. And he's like, oh, that's just the tip of the iceberg. That's like 0.00001% of what's possible. He envisions a world of what is called the metanet. We call it the metanet because his view is that one day the Bitcoin blockchain will subsume the internet, and that you can operate the entire internet through the blockchain. And the advantage of it is that if the internet is operating with the blockchain, you have the same data structure, the blockchain, recording both payments and content data. I view it this way, and this is how I describe it to people who don't understand the technical intricacies. The internet now is a protocol for transmitting information, right? Email, it's how we get our website data to display onto a page or a mobile app. And then Bitcoin was designed to be a payment system, right? A blockchain that you could use to send payments. On the internet, when you want to access a website and watch something, let's say on Amazon, you also have to pay, but the payment occurs kind of at a different layer. There's a payment processor, that's linked into the website. The metanet is this concept of creating a universal system where the payment and the transmission of data can happen simultaneously in the same layer natively to each other, so that you can open up whole new business models in terms of how you can access and transmit data. You can take advantage of the security of the blockchain, its code base. I won't go through all these. The single communication channel and reducing the number of keys that have to be purchased. But an example of how you could use this is time access, where you could remove the need for a third party to monitor, for example, when or how you access a television show or movie on Netflix, right? Right now they use sort of intermediary databases to track whether you paid your subscription, right? But you could access individual files that are paid for and contained on the blockchain or accessed on the blockchain, and you can pay by the second. And you can have time limits where this person's access expires based upon certain keys that are encoded into the blockchain. So it's combining those into one, which is really powerful. Same thing with payment mechanisms, allowing the purchase and delivery of digital content to take place within the same blockchain platform as opposed to separating them. And so those are just early examples of where we think this is all headed. But the concept is to make the internet ultimately a subset of Bitcoin. If you can do what Unwriter did, which is create a serverless website that operates in a single Bitcoin transaction, what else could you do? We're just at the very beginning of all this. And of course, much more work has to be done. But this is why we think there will be one global public ledger, one global public blockchain, not 1,000 and not 1,000 coins. And that's what we think is important to take us back to the future. Bitcoin always had this potential in it. It had it when Satoshi birthed it. It took a circuitous route where some people veered in another direction. We tried to save it with Bitcoin Cash that was birthed by certain people, the Bitcoin ABC development team, and we threw our support behind it. And that went in another direction. And finally, we just said enough. We decided to take a stand, fight for the original Bitcoin vision. That's why Bitcoin SV is here, is to take us back in time to get to the future. And that's critical to understand why Bitcoin, Satoshi vision, really is back to the future, the great reset, what we believe is the all-in-one coin, and the global public ledger for the future.